Just a quick update. I was asked to do a 2.5D animations. So what I did is, just for the examples, I took the side scroller example content that you can add by add new features or content pack, and I've just added the standard side scroller that is not a complete 2D, but it's a 3D. And how it is being set up is that you have a character that only moves right and left. He doesn't even have inputs for that. And inside the character movement component, you have this planar movement, and it has a planar constrained normal x1, which means that he can move only on the x-axis, and he can't move he can't receive inputs on different axes than the x-plane. So yeah, just save it, play, and we already switched animations. Those are the mockup animations, and you have the yes, we have jumping and landing. I think the jumping would need this is landed, this is jump. This need a bigger blend on start. That would be like 0.2. Let's see now. Yeah, that's a lot better. So now he has jump and land montage. And yeah, he's just running the standard mockup animation. You can see that he is not really just facing left and right because he's turning, and you can actually freeze turning in an angle that you would be looking forward. And for any game where you have enemies coming from the left or enemies coming from the right, that would be terrible, because we want him always to face left or always to face right based on our input, and we want to be able to move in depth of the screen and toward the screen, but only on limited angles. So let's jump into doing that. Okay, I'm back. I've just copied from the top-down character example the camera-based movement, and I've just inputted here. I've moved jump from event graph into input. So now in event graph we only have begin play, this neutral pose startup, and jumping and landing montages, and that's it we have. And also in the character movement component, I've just set this planar constraint to nothing, just disable planar constraint. We don't want to be constrained by planes. And now that we hit play, we are receiving inputs in all directions based on our camera position. And he's also sliding terribly. We have to fix that as well. Let's go into movement component. Let's see what did it change. Auto rotation to move. Okay, that's being override, so we don't mind. Air control. Okay, 0.8. Okay, ground friction. Yeah, obviously. Gravity scale. Let's change it back to 1 and see. Now he will probably jump super high and awkward. Yeah. And fall really slow. So let's get back here. Okay, we don't need this guy anymore. Let's get back here, character movement, and gravity scale back to 2. This is probably why his jump velocity was increased. Let's run, and yeah, he can now jump into things and he can move. Okay, yeah, but he's no longer bound by any constraints, so he can actually move here, he can move here, but we want to limit his movement front and back in some way. So why not just not do that? Let's get a blocking volume, and we'll set a blocking volume here. Where is our blocking volume? What the hell happened? Yeah, focus. Okay, and we want our blocking volume to be, well, definitely bigger. And let's say that this is X, so this is Y. Let's make it 2000. Okay, let's make it 20,000, and let's make the Z 10,000. Okay, so it's huge now, and let's then Alt Shift and make a copy of it and pull it forward, and that's all we're going to do. And we are now moving between those two blocking volumes. Now we set those blocking volumes and we go into collision preset. Okay, invisible wall. Can character step in? No. Custom. So ignore visibility, obviously. Block camera, obviously not. We are facing the camera this way, so toward the blocking volume. Object blocking, word static, ignore. Word dynamic, ignore. Pound, definitely block. Physics body, we could constrain our ragdolls by this, but let's say ignore for now. Vehicles, ignore. Destructibles, ignore. General overlap events, no, because we don't have overlaps, and that's it. Save, play, and now we should be able, yeah, just run toward the wall, and we will be forced to stop. And we are now limited with our movement to spots that we wanted. We could just move the back wall closer. That would have the similar effect, really. If we don't want invisible walls, so we could take this invisible wall back and just move here. Okay, so now we are constrained by a physical wall on the back and invisible wall in the front. Let's hit play. Yeah. And yeah, we are moving between wall and invisible wall, and we can move in all directions, but we are still not facing the direction we want. So we're gonna have to do something about that now. So first of all, we definitely need to be set up aim offset, turn rotation. We definitely need to rotate. Character rotation, no. Desired rotation. This is what we need. So we are trying to be strafe walking all the time that we can. And it is based on our aim offset. So let's see what will happen now. Okay. Okay, this is funny. But yeah, he's not facing any direction and he is not strafe walking because those animations don't have strafe walking. So let's change our base pose from mocap basic to starter iron sight. Play. Okay, and now he has strafe walking, so he's strafe walking to the wall and to the camera, and he's properly walking backward and forward with the animations, with angles and everything. But we want him to turn when we are moving backwards, and we want him to face forward when he's moving this direction, right? Okay, how to do that? It's very simple. Let's get tick, and on every frame we will take we could take any character movement component. We could get last input vector. However, if we want to use this on multiplayer, we should actually get acceleration, current acceleration, and current acceleration, like the description says, returns current acceleration computed from input vector each update. But this is readable on multiplayer, and this is readable only on actor that is giving the input, so only on the owner. So we're getting the current acceleration, and then we need to get actor. You know what? We need to get dot product, maybe, of two 3D vectors. Okay, we need to get horizontal dot product. No. for this quick pause. So we're getting the current acceleration, we are normalizing it, and then we are, or even less than that, and then we are just printing to the screen, and let's see how does it look like when we are running in direction. So y minus 1 1. Okay, so everything is based on y. Okay, that's easy. So we are taking this normalize split structure. Y is greater or equal 0. Then set control rotation. Get controller. Set control rotation. Yeah, okay. So on tick we are setting control rotation. We could do it in the controller itself as well, but we will do it in the pound. It's faster that way. So if okay, new rotation, select, and we will have two rotations, one that is left and right, and the rotation. Okay, how do I don't remember which one it was. Let's just pick it real fast. Okay. Okay. So let's do it like this. Branch. Got it. Finally got it. Okay, so if we have an input and we have some acceleration, and only then we need to on tick set our controller rotation, and our component is taking care of the rest. It's taking care of the aim offset, which is set to aim at, and it is also taking care of the rotation, and rotation speed is 720. And you know, it's desired rotation, so it's always trying to rotate toward the angle. So based on our acceleration, if it's the y of this vector is above 0 or not, we are getting the camera rotation, world rotation, and then we are adding a z90 or a z minus 90 to that rotation and setting this as our control. Why do we set it like that? Because if we have our character here and we place him at an angle and we play, he will still hit the camera angle. So it really doesn't matter if we do it or not. However, if we go into this guy, did I set? Yeah, z-90, that's fine. But if we go into this guy and we go into spring arm and we will change the rotation to, let's say, not 180 but 165. Yeah, play. Okay, so now we are moving at 165 and we are still getting input based on that camera. So you can see that he's moving left and right of the camera angle, which means that at runtime we can change the camera angle based on the location of the character, and we can get him to move on you know, slope like this, and then we can twist the camera and start moving normally. And I'm going to make a small example. 180. Okay, and tick, and let's make a sequence, and on 0 this is the, we'll just collapse that and call it set aim based on camera. Okay, so we got this. tick event, and let's make now an input of Q keyboard and E keyboard input. Okay, and on those presses we'll take the spring arm and add rotation and add, well, I think relative, add a delta to the rotation of the component. Oh yeah, so we'll add relative rotation on both of those presses, and it will take the Z rotation and it will add 15, and this will add minus 15. And this is something we would not run on input, but I wanted to show how it works. Yeah, obviously spring arm. So we could have a part of the game where we are, you know, moving sideways, and then it just turns on angle, and you can move this way, and then it moves again like this, and then it goes like this, and you are always moving like the camera is allowing you to. So you could, for example, boom, 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 go around the corner. Okay, but those walls actually should block camera. Wall, 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 and collision. Custom camera. Oh, they are blocking camera. That's interesting. So this is probably not doing collision test. Oh, that sucks. Okay, let's do it again. Play. So we're side scrolling, we're getting to an angle, and then the game turns, and we are now playing on like this. And then it turns again, and we're moving into here once again. And we can still jump and use our air control to go in depth and closer to the camera. Oh, that's interesting. Okay, so that will be something to sort out, but even graph. So maybe when acceleration is higher equal 0. And let's see now. No, he's still turning. Okay. Okay, when the acceleration y is greater, not the length of the vector. We got it here as well, so we don't need to put it twice. Now it should not turn when jumping. Let's see. Yeah. And now he is. Okay. Absolute acceleration is greater than this, and let's just make it more clean. Thank you for this plugin. Let's play again, and let's see. Okay, I am now jumping, and I am not turning until I actually want to turn. Okay, I think this is what we were aiming at. And let's add one more thing. Let's add a variable that would say, let's call it use mouse aim. Okay, and on use mouse aim, if it is true, okay, let's make another custom event. Or you know what, let's do a custom event from this, because this can be called from anywhere, because that's an interface and we don't have to cast to side scroller character. We can just call this event and just know the event names. So we'll add another one, and this one will be called how do we call it? Mouse aim toggle. Okay, and now all this we can actually just collapse nodes, and we call it neutral pose. Okay. And then from here we'll get not set, so this is a toggle, and now based on this variable, oh no, we're going to do something different. Get controller show my it has to be cast to player controller. Good, we're not doing it at tick, but only when we call the event. Show mouse cursor set, and it is the same as use mouse aim. Okay, and collapse node toggle mouse aim. Okay, this, and here you can just delete that. Okay, format, that's okay, that's better. Save, and input, no, event graph. Now we have this as well. Add, and this is false by default, so it is as it is right now. And now on tick, set aim base, and this base rotator, we're gonna need a new one. So we would have to get would have to actually use okay, let's add a controller. It's the player controller, side scroller PC, and let's just add it to our here. Okay, and in this we will go to class default, we'll add the example interface, and in the example interface we get get mouse position info, mouse by channel, under cursor by channel, trait complex, yes, hit results, yes. Okay, thank you. And no, this is everything we need. So this entire thing is here, this is here, and if this is false then it goes here, and we compile, but if it's true we're getting here, and from here we are getting here, and just compile. I'm going to do this all the freaking time. Okay, let's see. Default 1. Oh, not exactly. No, not exactly what I was aiming at. So maybe let's do it like this. Instead of this, we'll just recombine and new rotation. That's it. We are probably overcomplicating things as usual. Let's do it like this. And now this you can hide, and we comment and we call it aim at mouse cursor. And this will be aim direction and format. Thank you. And maybe not fast stop, but let's do it like this. Yeah, that's a lot cleaner. Thank you very much. And let's see, play. Okay, left, right as we wanted, 1, and now we are moving left and right, and we are still constrained, but we are aiming where we are aiming, but we are also aiming in depth, so if we can move in this dimension, we should also be able to aim in this dimension. I think this is quite obvious, and yeah, that makes us unfortunately spin like that. We could do something about it as well, but I kind of like it like this. And it is 2.5D. And if we want to go even further, we could add another blocking volume. That will be, for example, here. Where the hell is it? Okay. Okay, let's say it's going to be here, and let's say it's going to be just this wide, and let's move it a bit further, and then we'll make it really big. We'll make it high, and what it will do, we will make it go a bit further back. Okay. And we'll go into details, we'll go into collision, we will make it, we'll make it custom, and we'll make it to block visibility. That's not good. Let's do a block camera, and in here when we're doing our tick, we'll actually hit camera, not visibility. So it doesn't block visibility, but it does block camera, and doesn't block anything else, but it does block camera. Okay, save and play, and 1 and 1. Okay, so now, okay, it's a bit too close, but you can see that I am not really aiming at the back, I am aiming at this invisible plane I've just added. And yeah, that's terrible. The way you should do it for this invisible plane, you should make a new collision trace response, so a new channel, and this channel should be just the aiming channel. And thanks to that, you could have your character aim at the exact plane that you want him to aim, or exact actors you want him to to block. So for example, only enemies, only your invisible plane and enemies block this channel, so only they can be targeted by your actor. So yeah, those are the basics of the 2.5D, and yeah, let's remove this one for now because I'm not adding a channel to the project. And yeah, this is a small example. See you guys next time, and send me more requests. I'm really enjoy doing them, and I am posting this example to the repository right now.